I have 29, 2 more girls. Okay. So I will start today's lesson. So that day we stop at before inverse functions. Okay. So far, seldom any of you ask me questions. I don't know whether y'all can do all the questions, I hope, because there is no questions from you. Okay. So if you look at your textbook, okay, come we look at the textbook page. Okay, look at page 20. Okay, this is the one. Okay, we're still using the same book. Okay, MS 1. Okay, because we are still inside the chapter 1. Okay, so you please write your index for today. Okay, inverse functions. This is the index for today. Okay, today is 15. Okay, you look at this. Okay, I give you 2 minutes. Okay, to go through this. Okay, you see, US is a spatial country. Okay, most of their measurement unit are different from us. Okay, we are using SI unit. Okay, you learn from science, SI unit. Okay, so mostly their measurement unit are different. Example, this measuring the temperature. Okay, we are using degree Celsius. Okay, but they are using a degree Fahrenheit. Okay, so this is the conversions from Fahrenheit. So how to say, from the degree Celsius to Fahrenheit. Okay, so it means if we know the temperature in degree Celsius, then we put in here, then we will get the answer in Fahrenheit. Okay, if another way around, okay, we have the temperature in Fahrenheit. Okay, then how we want to get back the in degree Celsius? So actually, very simple. We just change the title, change the subject. Sorry. Okay, change the subject. This one you have learned during your lower form. Change the subject. Okay, so how you change the subject? Okay, if I write in this way, F is equal to 9/5 C plus 32. Okay, you want to change, now the subject become the C. Okay, so you let the C stay here, you move this 32 to this side, so plus 32 become minus 32. Okay, first step. Next, the C stay here. Okay, or you can write A equals B, B equals A. The whole thing left and right just change. So 9/5 C equals to F minus 32. Because always the subject, we would like it to stay at the left hand side. Okay, so next, this one times, okay, so become here, become divide, okay, or upside down. So become 5/9. Okay, then F minus 32. Okay, this is how you change the subject during lower form. Okay, so actually changing subject these are actually like we are doing inverse functions. Okay, so okay, so afterwards when you want to find the inverse functions, actually you are doing this. you are doing the changing of the subject. Okay, so example, y is a subject. After you want to find the inverse function of the y, okay, the subject will become x. Okay, so if x is the image, now will become x will become the object. Okay, the object will become the image will become the object. Okay, so you are changing the subject. Okay, so this is inverse function. So you remember inverse function is changing the subject of the functions. Okay. Okay, next we're going to look at this. Okay, we try this. Okay, I try to open this file. Okay. Okay, so you see, actually this 3x and the x over 3, this one and this one is the inverse of each other. Okay, so this one will show the graph. Okay, this one straight away they draw for you the graph. Okay, 3x, and then the inverse of 3x is x over 3. Okay, this is the graph. Okay. This one is wrong. The gx is wrong, so I don't click on this. Okay, and then this is y equals to x. Y equal to x. Okay, the green color one. Okay, this one they want to let you know, actually they want you to see whether the graph of each function and its inverse symmetry about the line hx equal to x or not. Okay, hx equals to x, this one actually is y equal to x. Okay, so you see this graph, the red color one and the blue color one, okay, they are symmetric, okay, about the green color line. Okay, okay, this is f. I uncheck this. Okay, we try p. Okay, 3x plus 5, and the inverse is x minus 5 over 3. Okay, again you see, okay, it's symmetry. Okay, so this is one of the properties for the inverse function. Okay, their graph and their inverse are symmetry about this line. Okay? Okay, so remember this line is the y equal to x. Okay, so we come back to the textbook. Okay, so you see here. Okay, this one maybe you can write in your notes. Okay, this you see or not, y equal to x. Okay, found that every graph of the function and its graph of an inverse function, okay, is symmetry about this line. Okay, you don't write this line. This line you maybe will confuse you. Okay, you can just write symmetrical about, okay, y equal to x. Okay, this line I think you know, y equal to x. Okay, and then what symmetry, okay, is the function and the inverse function. Okay, they are symmetrical about y equal to x. Okay, another way of saying, you can say that the graph, okay, the inverse is the reflections of the graph of the f in the line y equal to x. Okay, these two have the same meaning. These two bracket, okay, these two sentences have the same meaning. Okay, okay, you can write this also. Okay, this is a symbol of the inverse function, f and then power -1. This is a symbol of the inverse function. This one, okay, is inverse function. Okay. So you remember this. This is very useful. Okay, this is very useful. Okay, if you write y equal to fx, okay, you can write x equal to f inverse y. Okay, these two. Okay, after some we use a lot for this. Okay, so this one also you can write in your notes. Okay, then these are mapping also. Okay, so you see okay, object is x. Okay, through the function f, okay, you get y. So y is the image. Now the other way around, from the y you come back to x. Okay, so now y become your object. Okay, from the inverse function you will come back to the x. Okay, become your image of the inverse functions. Same like just now, from the degree Celsius you want to change into Fahrenheit. Then from the Fahrenheit you want to change back to the degree Celsius. Okay, so one is the function itself, the other one will be the inverse functions. Okay, we go to next page. You see okay, the sign -1 used in the f, okay, -1 here, okay, does not mean the reciprocal of the f. This one not mean this. This one I have to be careful. Okay, but okay, this f -1 is a inverse of the f. Okay, why you say so? Okay, you remember like example 2 to power of -3. Okay, this one you have learned before. 2 to power -3, actually this one you can write it as 1 over 2 to power 3. Okay, this negative mean bring the meaning of the reciprocal, but this negative doesn't mean bring the meaning of the reciprocals. Okay, so this is what they want you to know. Okay, now we look at this example. Okay, you go through a while. Okay, this function f, it maps x to the y. So x as object, y is the image. Okay, that means this. Okay, the inverse of 1 over 4. Okay, so the inverse of 1 over 4, you have to look at this. Look at the image of the f. Okay, so the image of the f, 1 over 4, okay, map back to the object. Okay, so actually, okay, from here to here is f2. Okay, you will get 1 over 4. So the inverse of the 1 over 4, you will get back the 2. We use back just now. This one. We use back this one. Okay. Okay. So what's the answer for the inverse of the 1 over 4? You get 2. Okay, same as this. Okay, 3. F3, you're getting 5. Okay, so the inverse of the 5, okay, you're getting back 3. Okay. Now we go to example 40. Okay, they give you the functions. Okay, x over x minus 4. Okay, determine the image of 2 under f. Okay, this is simple. Okay, the image of 2 means they're asking for the image. Okay, object is 2. Okay, so you're finding f2. Okay, so just substitute 2 minus 4. So you get -1. Okay, we go to part B. Okay, how about this? Okay, So you set this one because you didn't learn how to find the inverse function yet. You want to find the inverse function also can. Okay, you want to find the inverse function same like just now. You set a what? You know, the change of the subject like just now. Okay, but now I don't show you by using that methods. Okay, since here they are not putting x okay, they are putting a number. I can let this, okay, be an unknown. Okay, here they use a, so you use the same thing, a. Okay, and then from what you learn, just now, this still come back to this. Okay, okay, so you know that fa is equal to 3. Okay, fa is equal to 3, so the inverse, okay, of the 3 will get back to a. Inverse of the 3 will get back to the a. Okay, so now fa, okay, fx is x over x minus 4. fa, okay, now the x become the a, so it will become a minus 4. Okay, so if this is b, fb, then this one will be b over b minus 4. If they say this is c, then this one will be c over c minus 4. Okay, and etc. Okay, then equals to 3. You see, you follow fa now become this, equals is equal, 3 is 3. Okay, now solve for what? What you're going to find? You're going to find a, because you let the inverse of 3 be a. So now actually you want to find a. So now from here, from these equations, okay, you're going to find a. Okay, so next, this one come here. Okay, divide become times. Okay, then expand 3a and then 12. Okay, I will let the 3a stay here. Okay, I will let the a come here, minus a. I let the minus the 12 go here, become positive 12. Okay, 3a minus 1a is 2a. Okay, after that, I can change a is good. A equals b, b equals a. So I just change in this way without changing their sign. Last step. Okay, 12 divided by 2. So I get 6. Okay, therefore, right back. Okay, what is the questions they're asking for this? Okay, the inverse for 3. So what's the answer? A. A is what? 6. So this is 6. Okay. So this is example 14. Okay, so this one will be your today homework. Okay, then after this, making and verify conjecture related to the properties of the inverse functions. We have a 1, 2, 3, and then 4. This one is quite long. I go through a little bit first, so then we continue on the Thursday. Okay, so you continue in your notes. Conjecture. Okay, so you have a few properties okay, you want to make a conclusions okay, so this is your first properties. If you drag down your textbook, okay, the box one always you can write in your textbook. Okay, so this is your properties number 1. Okay, a function f that map set x to set y, okay, has an inverse functions. Okay, f inverse, okay, if f is 1-to-1 functions. Okay, so now you want to know f is 1-to-1, only you will have inverse. Okay, if not, you got no inverse. Okay, now we want to prove it. Okay, you see here, you look at this activity. Okay, we look at the first part. Okay, I give you some time to go through. You don't have to copy this actually. Okay, you just go through all. Okay, you look at the functions. Okay, x squared. Okay, so if the input is x, okay, so square it. Okay, -1 times -1. Okay, you get +1. Okay, -2 times -2. Okay, square it. Okay, so you get +4. Okay, this one same thing. 1 times 1. Okay, you get 1. Go wait for a while. Okay, you continue. Okay, for the inverse also the same thing. Okay, you can do it on using pencil maybe in your textbook. Okay, I come back in a short while. Okay, come back. Sorry. Okay, so this one square it, you get 4. Okay, the inverse. Okay, the inverse is the other way around. Okay, so the 1 from here. Okay, the inverse is this way. The 1 okay, so you see -1 go to 1, 1 go to 1. So the other way around is from 1 go back to -1, 1 go back to 1, 1 go back to -1, 1 go back to 1. Okay, 4 the same thing. 4 go back to -2, and then 4 go back to 2. Okay. Okay, then we look at the B. Okay, we do finish first. We do the mapping finish first. Okay, so the function h is x plus 2. Okay, means the object plus 2. Okay, so -2 plus 2. -2 plus 2. Okay, so it's 0. Okay, 0 plus 2. 2. 2 plus 2 is 4. Okay, 4 plus 6. Okay, so this one, the inverse the other way around. Okay, 0 map back to a -2, and then 2 map back to 0, and then 4 map back to 2, and then 6 map back to 4. Okay. Okay, now they want you to answer the following questions. Okay, if the inverse g and the inverse h functions or not. Okay, you still remember functions? Okay, one-to-one relation. There are two types of relations which are functions. Okay, first type is one-to-one. Second type is many-to-one. Okay, only these two types are functions. Okay, so this one is many-to-one. Okay, this is one-to-one. Okay, this is one-to-one. this one will become 1 to many. Okay, so you see, okay, if your original function is many to 1, your inverse will become 1 to many. Okay, 1 to many itself is not function already. Okay, so this is not a function. Okay, if your original function is 1 to 1, then your inverse function is still 1 to 1. Okay, so the inverse function is a function. Okay, so now can you answer the question? What type of a function will yield an inverse function? Function means the inverse itself is a function. Okay, what type of the functions? It's only 1 to 1. Okay, if many to 1, okay, if many to 1 function, it will not give you a inverse function because the inverse itself is 1 to many. 1 to many is not a function. Okay, so from here it proves this, the first properties. Okay, a function f, okay, has an inverse function if f is 1 to 1 function. If f is not a 1 to 1 function, okay, it will not have an inverse function. Okay, so this is for the first property. Okay, I hope I'm clear. Okay, this is a very long this subtopic. Okay, now I think I can go through one more or two more the properties. Okay, this is the second properties. Okay, we go down some. Okay, this is the second properties. Okay, this one you can copy. Okay, sorry, we start from here. It should be okay. Start from here. Okay, the function f and g are the inverse functions of each other if and only if. Okay, fgx equal to x. X is the domain of the g, and g fx is equal to x. X is the domain of the f. Oh, what's the meaning? Okay, let us see the example. Okay, we go through this activity. Okay, you can go through a while. Okay, maybe you see the title here are more clear. Okay, if you have this kind of composite function, okay, you remember you learn a composite function, you find fgx, you find gfx. Okay, if your fgx is equal to x, and then your gfx also is equal to x, okay, actually, okay, it brings the meaning of function f and function g are inverse of each other. Means the g is the inverse function of the f, and then the f is the inverse function of the g. Okay, this is the meaning. Okay, now we want to prove through this activity. Okay, so we continue. The arrow diagram on the right shows the discrete function f that map set x to set y, and the discrete function g that map set y to set x. Okay, so this is function f, this is function g. Okay, function f it map from x to the y. Function g it map from the y to the x. Okay, we want to prove this. We want to prove this. Okay, if you look at this mapping diagram, you will know actually g is the inverse of the f. Okay, and then same thing, actually f is the inverse of the g. Okay, complete the empty box below. Okay, based on the arrow diagram on the right. Okay, so we fill out the balance. Okay, so from the function f, okay, it map 1 to 1, 2 to 3, 3 to 5, and 4 to 7. So 3 to 5, and then 4 to 7. Okay, now look at function g. Okay, it map back 1 to 1, 3 to 2, 5 to 3, and then 7 to 4. 5 to 3, and then 7 to 4. Okay, now you find 1 by 1. Okay, you find 1 by 1. Okay, so This one I don't want to go through with you. I straight away go to this. Okay, F3, F3, F3. I can see here F3 is 5. Okay, G5, G5 I can see here. Okay, 3. Okay, next G5, G5 is 3. Okay, F3, F3 is 5. Okay, I continue this. Okay, F4, F4 is 7. Okay, G7, G7 is 4. Okay, next G7, G7 is 4. F4, F4 is 7. Okay. I don't know whether this is proof or not. It's X, X, X. 3. It should be 3. 5. It should be 5. 4. It should be 4. 7. It should be 7. Okay. Can you see this? Okay. If GFX is X, GF3 is 3. Okay. FG5 is 5. GF4 is 4. FG7 is 7. Okay, we see here the same thing. GF1 is 1. FG1 is 1. GF2 is 2. FG3 is 3. Okay, so you can see same. Therefore, it says that. Okay, FGX is X or GFX is X. So the F and the G are the inverse for each other. Okay, so it proved through this activity. Here is 1, here is 1. This is 3, this is 3, and this is 5, this is 5, and this is 4, this is 4, and when this is 7, this is 7. Okay, so this is the meaning. This is very dry when you want to prove something. Are you still there? Anyone on the mic? Are you still there? Yeah, okay, very good. Okay, so for the second property, you can write this. Okay, you can write this. Okay, if you feel this is a very don't know what it's saying, okay, you can write this. F G X is equal to G F X is equal to X. You can replace this, okay, with this. Okay, you just start with the function f and g are the inverse function of each other. If and only if, then this fgx equal to gfx equal to x. I think this one is easier to understand. Okay, so this is a second property. I can go through one more property. Maybe I can finish all the property. This one I have checked already. This one there's a mistake in the drawing, so I don't want to go through with this. Okay, so I straight away let you see the third properties. Okay, so this one is the third properties. You can copy down. Okay, if two functions f and g are inverse function of each other, then okay, this is actually quite simple. The domain of f is equal to range of the g. The domain of the g is equal to range of the f. Okay, then also this one you have learned earlier. Okay, part the graph of the g is the reflections of the graph of the f at the line y equal x. Okay, this one you have learned it earlier part. Okay, so this is the third properties. Okay, you see got so many properties for these inverse functions. Okay, then we come to the fourth properties. Okay, property number 4 is here. Okay, this one is number 4. Okay, this one I can try. Okay, let us look at this website. Eh, why? Something wrong? Oh, okay, that wrongly. Okay, very good. Okay, so you know already the functions and the inverse, okay, is the refractions along the line y equals to x. Okay, now they want to see the point by point. Okay, so I go back to the, okay, you look at this. I want you to concentrate on it, maybe this part. Okay, for any real number AB, if the point AB okay, lies on the graph F, then the point BA lies on the graph G. Okay, that is the graph, okay, inverse of the F. Okay, let G be the inverse function of the F. Okay, if AB is on the graph F, then BA will be on the graph G. Okay, you know, right? Image and object are terbalik. Okay, for the inverse function. So AB will become BA lah, huh? Okay, so let us see this one. Okay, you see this point? You see this point? It's at 2, 4. Okay, 2, 4. Then the inverse is at the 4, 2. Okay, now I drag. You can see the inverse is moving. Okay, so now the point is at the 2, 6. So now it's at the 6, 2. Okay, I move some more. Maybe this is at the 3, 3, 9. Okay, then here at the 9, 3. Okay, so this is the meaning. Okay, so this is the fourth properties. Okay, the textbook. Okay, one more thing. I have 7 more minutes. Okay, maybe one more parts. I cannot go through all. Okay, but one more parts we go through. Okay, you still remember vertical line test? Vertical line test. Okay, maybe I can call a girl. Emmeline. Am I right? Emmeline. The first girl in the list. Emmeline, can you on your mic? Do you have a mic? Cannot enter. Restarting. Okay, Emmeline. Oh, you got no mic. Okay, can you answer me? Do you remember vertical line test? Can you tell me the purpose of the vertical line test? Can you tell me the purpose? Okay, to determine whether it's a function or not. Very good. Okay, now we have a horizontal line test. Okay. Before that, we have a vertical line test. You want to test whether the function, the relation given is a function or not. Now we have a horizontal line test. Okay. So horizontal line test is to test whether the function has an inverse function or not. Okay. So to determine whether the graph of a function has an inverse function, we do vertical line test. Okay, so this one you can put in your notes. We do vertical line test to do what? To determine whether the graph of a function has an inverse function or not. Okay. Then this is okay. How we determine they have inverse function or not. Okay, if the horizontal line cut the graph of the function at only one point, then this type of graph is one-to-one function and it has a inverse function. Okay, so 1 point, then has an inverse function. Okay, look at the example. Okay, horizontal line. So you do this way, horizontal line, the blue color one. Okay, you do horizontal line test. Okay, it only cut 1 point. So this function f has an inverse function. Okay, you look at the second example. Look at the second example. Okay, you do horizontal line test, the blue color line, it cut the graph 1, 2 points. So this function f does not have an inverse function. But when you do vertical line test, Okay, verticalized test. Okay, it only cut at one point. So this graph is a function. F is a function, but it just F does not have a inverse function. Okay, so now we have learned these two tests already. One, you remember, one is vertical line test, one is horizontal line test. Okay, I think I will just stop here. So you only have one homework for today, okay, which is self practice 1.8. Okay, so we will continue the lessons on coming Thursday. Okay, Thursday we have lesson. Okay, wait for a while. Okay, I want to stop recording.